Good day, learners. Welcome to today's session. In this session, we'll be looking at analytical geometry from paper 2. So, question 1, we are given a sketch below with points A, B, and C, and also their coordinates. So, if we can check question 1, 1.1.1, we are asked to calculate the line or the length of the line AB. So when they ask us to calculate the length of a line and we're given the coordinates, what do we have to use? We have to use a distance formula to calculate AB. Okay, so let me put it here. Question 1. Okay, 1.1.1. So we have to use a distance formula. So you need to remember the distance formula. Sometimes they can give you this formula. Sometimes they expect you to know this formula from heart. So this is what? This is x2 minus x1 squared plus y2 minus y1 and you square. So about here, you square, you put a square there. So this is the formula of a distance formula. So we need to label our points first. This will be what? Our x1, y1. And then this will be our x2, y2, right? So we need to label our points first. And then next thing, we need to substitute our points into this equation here, right? So what is our x2? X2, it's here. You can see it's 1 here. Okay, so you need to put 1. And then what is our x1? Our x1 is negative 2. You can see there. Okay, so it will be minus 2. Okay, and then you put brackets and you square it. And then our y2, what is our y2? Our y2 is 2. Okay, our y1 is negative 2. Again, we do what? We minus bracket minus 2 and then we square. All must be inside the square root. Okay, and then now we simplify everything inside the square root. And then now we'll have 1. Negative times negative is what? Is positive. So it means we'll have 1 plus 2, which is 3 squared. Y squared? Remember, we're squaring this, right? So don't forget that. And then here we have 2. Negative times negative is what? Is positive. So 2 plus 2 is what? Is 4. So we have 4 squared. And then we simplify further. We have 9 plus 4. What is 9? 9 plus 25, because the square root of 4, I mean the 4 squared, it's 25. Sorry about that. Okay. And then we need to add, sorry about that. 4 squared is 16. Sorry about that. And then we need to add 9 and 16. What is that? Is 25. So you have square root of 25, you have 5. So it means that the distance here, AB, is what? It's 5 units, right? So you need to write AB is 5 what? Units. Because it's what? It's distance. So they didn't give you if it's centimeters or meters, so you can just say 5 units. Okay, moving forward to 1.1.2. Okay, 1.1.2, They ask you to determine the coordinates of point D, these coordinates here. If point C, this one is a midpoint of BD, right? So point C is the midpoint of BD. So what do we know? We know the midpoint formula, right? So I also suggest that you should memorize this formula because you may get this formula or not. So the best or the safe thing to do is to memorize this formula. Okay, so the midpoint x and y will equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2, right? We put brackets everywhere, right? So this is the formula of the midpoint. Sometimes they can put xa plus xb divided by 2, the coordinates here, ya plus yb divided by 2. So they can put it in different ways, but it's still the same formula. So what do we know? We know that from this equation here, the coordinates of these are the coordinates of the midpoint, right? This this is the x coordinate of the midpoint. This is the y coordinate of the midpoint. So we know that the coordinate of the x coordinate of the midpoint or x midpoint, right, will equal to what? X1 plus x2 all divided by 2, and then we have what? Ym will equal to what? Y1 plus y2 divided by 2. So this is the same as this equation. We're saying that this is the value, x plus 1, x1 plus x2 divided by 2 is the x coordinate of what? Of the midpoint, right? So this xm will equal to this, and the x coordinate of the y coordinate of the midpoint here will equal to this here. So you need to understand how to derive this equation from here, right? And then now you'll need to label your coordinates again, right? You can remove this one, okay, and then this one you can label this one as your x1 again, y1. These coordinates of D here, you don't know them. You are looking for the coordinates of D, okay, and then you'll have what? X2, y2, right? So you are looking for these coordinates, but you have the coordinates of what? Of the midpoint, because they told you that BD, the line BD, C is the midpoint, right? So we already know the midpoint. We know this, right? X coordinate of the midpoint and the y coordinate of the midpoint, but we don't know what x2 is and y2, right? These ones. So we need to substitute everything into this equation here. So let's substitute with what we're given. Okay, what are we given? Do we know the x coordinate of the midpoint? Yes, we know the x coordinate of the midpoint. It's 2. Okay, so we'll have 2 is to okay, 2 will equal to what? This one here will equal to x1 plus x2. Okay, what is our x1? Do we have x1? Yes, we have x1. x1 is 1 plus x2. x2, do we have x2? No, we don't have x2. This is what we are looking for. So we write x2 here. Okay, all divided by 2. right? So we need to simplify this. How can we simplify this? We can cross multiply or multiply by 2 both sides. So it's up to you. Okay, we can multiply by 2 both sides. Okay, so that we get rid of these 2. Okay, here we'll have 4 and we'll have 1 plus x2 because these will cancel, right? And then x2 will equal to 4 minus 1, which is what? Which is 3, right? So we found our x coordinate here, right? X2 will equal to what? To 3, right? So we what we need to find next is our y. So the y will use this formula, right? Y midpoint will be y1 plus y2 divided by 2, right? So we know our y coordinate of the midpoint. Yes, we know it's 0. You can see here it's 0. Okay. So we'll have 0 equal to, do we know y1? Yes, we know y1. Y1 will equal to what? Will equal to 2. Here, you can see 2 here. Okay. So it will be 2 plus y2. Y2, we don't know y2, we're looking for y2. And then we divide by 2, right? We can do the same thing. We can multiply both sides by 2, okay? So that we get rid of these 2 here. Put brackets. We multiply by what? 2. And then here, we also multiply by 2, right? So 2 multiplied by 0 is 0. Okay, and then these will cancel here. We are left with what? 2 plus y2. What is our y2? Our y2 will equal to what? Negative 2. So it means that y2 here will equal to negative 2. Okay, so we have found our coordinates for D. So these are the D coordinates, right? Okay, and then moving forward, we are asked the coordinates are point E. Okay, we're told coordinates point E, right? Is P is to 1. Okay, P is to 1. Okay, we're given there. Now they ask us to determine the value of P if E, C, and A are collinear, right? So what does collinear mean? It means that they are in the same line or they fall in the same line. So A here, C, and E, they all fall into the same line, right? So if you can join a line, right? If you can join a line, this one, they will all fall into this line here, right? So that's what it means to be collinear. So if they fall on the same line, what does it mean? It means that they share the gradient. The gradient here at A, the gradient here at C, the gradient here at E, they are all the same because they fall under the same line with the same gradient, right? So it means that their gradients are the same, right? So knowing that, um, we have 2 points. We have A and C, right? A and C, we want E here. So how can we find E? We know that if we find the gradient of AC, okay, gradient of AC, okay, let me change this, okay, 1.1.3, okay, the gradient of AC, how can we find the gradient of AC? We know that the gradient of AC will have to equal to the gradient of what? Of CE. Will have to equal to the gradient of CE. Why? Because they fall under the same line, the line joining all these points here, right? So this line here, they all the points they have the same gradient. So it means the gradient of AC and the gradient of CE they have to be equal, right? Because they share the same gradient because they are in the same line, right? So how do we find the gradient of AC? Okay, can remove the points here. Okay, so this one we know how the formula for gradient. We can name this one our. It's very important to name your coordinates. Okay, we can name this one uh, x1, and then this one y1. This one we name x2, and then y2. Okay, so we have the two coordinates here. So from these coordinates here, we know the formula. The formula is what? Y2 minus y1 for gradient, x2 minus x1, right? Okay, so we name the coordinates here. Let's name this one as well. This one will be our x3, y3, right? So it means that we'll have what? Y3 minus x3, sorry, is y3 minus y2. So this y3 minus y2 all divided by x2 minus x1, right? Sorry about that. Okay, let me fix this. X3 minus x2. Sorry about that. It's x3 minus x2. So it's very important for you to name or label the coordinates so that you don't make a mistake, because you can see it's very easy to make a mistake. So what do you do? Okay. So what is your y2? Your y2 is 0. Let's start here. Is 0. You can see y2 0. Okay. Y1. Y1 is negative 2. Okay. Negative 2. X2. What is the x2? X2 is 2. Okay. And then what is our x1? X1 is negative 2. We can see it's negative 2. Okay. So negative 2, right? This will equal to what is our y3? Our y3 here is 1. Our y2 here is 0. What is our x3? X3 is p. You can see here from E. So it's p. And then x2. What is our x2? X2 is 2. Right? X2 is 2. Okay. So we just need to simplify everything. 0 minus minus 2, we have 2. And then 2 minus minus 2, we have what? We have 4, because it's 2 plus 2, which is 4. So we'll have what? 1 minus 0, we know is 1, and then p minus 2, right? So we just need to solve p minus 2, okay? So we can do what? We can simplify this further, because what do we know? We know that 2 divided by 4 can be written as 1 divided by 2. Okay, so we have what? We have 1 divided by p minus 2. Okay, so in this case, we can cross multiply, right? Or we just invert it, right? So it's up to you what you do, you'll get the same answer. Let's cross multiply. Okay, p minus 2 times what? Times 1. Okay, we'll have p minus 2. How do we cross multiply for those who don't know? The bottom one here, right? You multiply it with the top one here. So the denominator here, you multiply it with the numerator here, right? And then you do the same here. The denominator here, you multiply with the numerator here, right? So p minus 2 times 1 is p minus 2, right? And 2 times 1, what is 2 times 1? Is what? Is 2, right? So we need to write 2. Where do we write it? Here. So it will equal to 2. So what is our p? Our p will be 4. Why? This 2 will be positive when it goes to the right hand side. So it will be 2 plus 2. So this will equal to 4, right? So p will equal to 4, right? So we calculated or we determined the value of p, right? So the final one here, they ask us to what? To show that a, b, e, d, it's a kite. So a, b, e, d, it's a kite. How do we show it's a kite? Okay, we know that a kite, um, the diagonals of a kite, right? They must be perpendicular. So it's one of the properties of a kite. So I suggest that you do some revision of properties of a kite, right? So if the diagonals, this diagonal A, E, and B, E, right? They the the diagonals are perpendicular. So if okay, let me try to draw here. For them to be perpendicular, it means they intersect here at 90 degrees, right? So for it to be perpendicular. So how can we prove that? We need to find the gradient of AE, right? Or AC, and the gradient of what? Of BD. So if the product of what? Of the gradient of, because what do we know first? You see, the first question, we calculated the line AB, the coordinates point D, right? And then the point E. So we can determine the gradient of either BC and AE or AD. So we calculated the gradient before, right? We know the gradient of AC, right? The gradient of AC, remember when we were calculating point P, we found the gradient of AC. So this gradient of AC, this one, right? And the gradient of BC, this one, right? So if we multiply their gradients, we must have -1. So the product of their gradients have to be -1. So let's quickly, we know the gradient of what? Of AC. What is the gradient of AC? Okay, we calculated the gradient of AC here. We found it as 2 over 4, right? So let's write it here. The gradient of AC, okay, let me fix it here, is 2 divided by 4. So it means that the gradient will be what? 1 divided by 2. So let's calculate the gradient of BC, right? The gradient of BC will be what? Will be y2 minus y1 x2 minus x1. So we need to quickly label these coordinates. This will be our x1, y1, and then this will be our x2, y2. Okay, what is our y2? Our y2 is 0. So we have 0 minus what is our x? What is our x? Our y1. Our y1 is 2. So sorry. Our x2 is 2, and then our x1 is what? Is 1. So 0 minus 2. What is 0 minus 2? So we have negative 2. And then what is 2 minus 1? 2 minus 1 is 1, right? So the gradient here will equal to negative 2. So what do we know for the gradients to be perpendicular? The gradient of AC multiplied by the gradient of BC must give us what? Negative 1. So the gradient of AC, the product of the gradient of AC and BC must give us what? Negative 1 for it to be perpendicular. So let's check. AC gradient is what? It's half. And then BC gradient is what? Is negative 2. So half times negative 2, we get what? Negative 1. So we can conclude that can let me insert the page. Since the product of the gradient equals to negative 1, it means that uh, BC or BD, because you can see D is collinear with C, so you can say BD is perpendicular to what? To AE, right? So you can conclude that A, B, E, D is what? It's a kite, right? Why? Because the product of the gradient of BD or BC and AC, right, equals to what? Negative 1. So they are perpendicular, right? So part of the properties of a kite, they are diagonals like this one, B, D, and AE have to be what? Perpendicular, right? And they must intersect at 90 degrees. So if they intersect at 90 degrees, it means what? They are perpendicular. Okay. We have come to the end of today's video. Please don't forget to like and subscribe so that you can be notified when the next video is uploaded. Thank you.